Today we're going to talk about distributed energy generation, latest in renewable energy technologies. Distributed energy generation is energy provided local at a facility, generated on site, and it offsets the energy generated from other sources that's transmitted from utilities and other fuel sources. Today we're going to talk a little bit about really the facility energy management roadmap. What's the plan? In the context of that, where renewable energy technologies and fuels can play a part, how energy efficiency and generation technologies can work together, and talk a little bit about markets and market drivers, and then go through a summary. You really want to start with a facility energy planning roadmap. Build your vision for the future. This plan will incorporate first really the low-hanging fruit. You want to see what kind of operational changes you can make at your facility that don't have a lot of cost to them. And that is, not running the lights when you don't need it, trying to use smart controls to offset nighttime heating or cooling needs. The second part of this energy plan is really to reduce energy use through efficient technologies. You can start with energy and demand management controls. There's storage options that can offset energy usage during times that are high cost to low cost, and this can have a very high financial impact. You really want to consider doing these things first because you don't want to generate power for that which you really don't need to be using. Distributed generation is the production of energy. There's a lot of options there. There's renewable energy sources for both heat and electricity, straight electricity generation or cogeneration, and that can be part of a path to net zero or pure independence. On the path to net zero is where you generate all of your power on site. You can trade energy with the utility, but the idea is to get really down to net zero import from utilities. The first part of that plan is critical systems backup. What happens when you lose the grid or lose resources to run your facility? You really want to make sure you have a strategy for that. The net zero energy usage is kind of like the next level away from that, where you can completely control your energy costs, completely control emissions and your carbon footprint. And the last is real true energy independence, where you can generate what's needed on site when it's needed, and leverage efficiency, demand management, storage, and generation technologies together. Talk a little bit about renewable generation technologies, renewable fuels. In terms of energy, you have electricity and heat production. In the electricity generation, you have solar photovoltaics, which has been a significant material cost over the past 5 years. Wind energy, biogas fueled generators, these are all considered renewables. On the heat generation side, you have solar thermal, geothermal heat pumps, using the heat that's stored in the earth, heat from biogas electric generators, so you can have a combined heat and power system work together. There's also biomass boilers and furnaces that can work off of wood products, waste wood products. This is really where the rubber meets the road. It's the coordination of how all these things can work together. Starting out with the energy efficiency measures, I wanted to show the top line of the blue is the current usage throughout a particular day for a particular customer. The next level down this line is the reduced energy usage by not running things at night. This is all the energy efficiency, things that can be done to leverage not needing to purchase electricity from the utility. These measures cost far less than any technology related to generation. And you want to do this basically in any situation this is applicable. From the generation point of view, actually making power on site, you'll see you have baseload generation. This is something that runs all the time. It's not periodic with the sun shining or the wind blowing. And this generation technology can reduce both usage charges, total energy, but also the amount purchased at any one given time from the utility and the demand. There are renewable and non-renewable sources for this baseload generation. And again, it's heat and electricity. The weather-dependent renewables, solar PV, wind, these are all dependent on climate. They really only address the energy usage because it isn't available all the time, but can create significant savings for the customer. So we talked a little bit about what a particular day looks like, but when you look at an electricity bill, this top chart here shows a demand portion in red and the energy usage portion of the bill in blue. Energy usage, the larger section in this particular example, the high value, high impact is go after the operational changes and energy efficiency equipment and systems. The medium value impact on energy, intermittent distributed generation, that's the solar and the wind. It is available when the resource is available, and then the continuous distributed generation. On the demand charge side, or taking care of the power at the time that you need it. The demand charge reduction, the high value impact is absolutely all the energy, the operational changes that can be made, energy efficiency measures, and the continuous, always generating types of systems. Stationary storage systems, which you'll have an opportunity to take a look at, they can also displace demand into other time periods where it's less costly to run. The low impact, really the renewable generation technologies like solar and wind really don't have a large effect on demand, but they can. Markets and market drivers, it really depends where you are for the renewables. So dynamic markets, you have various electricity prices throughout the country, various fuel prices that kind of tie into the economics, availability and price of biofuels, solar radiation, certainly if you're in the southwest, there's a lot more sun than there is in the northeast, wind speed, ground temperature for geothermal systems, and heating degree days, cooling degree days. These all affect the various markets that you're in. So it's very individual. There's also regulatory requirements or like places where you can net meter solar energy that drive feasibility of projects, and certainly the renewable resources availability. So in terms of market growth, installations of really all of the various sectors for solar has been increasing year over year. What's interesting, the cost for solar modules, people have various data points for costs of solar. In just the past 5 years, solar modules have come down to 15 to 25% of the cost they were, 2008, 2009. And the entire project costs are less than half, easily. In some cases, 30, 40%. So you can see that the growth in the marketplace is really driven by the economics improving over time. New Jersey is number 2 in the country for non-residential commercial space, but Massachusetts, Pennsylvania, Maryland, and New York are in the top 10. So the top 5 are here, right on the East Coast. Federal tax credits, while they're still available, absolutely make projects more equitable. While they're still available, non-taxable entities that can't take advantage of that, there are other financing means or mechanisms, such as power purchase agreements. In summary, really starts with designing a long-term energy strategy for your facility or business. Know where you are and where you're going. Create or follow corporate initiatives and set goals. Within that plan, you're going to start with the low-hanging fruit. Adjust operations for energy reductions, incorporate energy-efficient technologies, and after all that's done, energy generation options from renewable energy sources, lower your carbon footprint, and then consider other distributed generation technologies. In the end, the goal setting is around moving towards energy independence, and depending on goals, maybe hitting the net zero or complete independence in the future. Thank you.